Hi everyone, welcome back. So today I will explain you how to build a linear model in machine learning. So in the simple linear model which handles the simple linear regression where you have the equation like y is equals to mx plus c, and this is where y is your dependent and x is the independent. Okay, now initially if I take consider the first step includes extract data. After that I will go to exploratory data analysis. I have to explain what the data contains. EDA. And the third step, after explanatory data, explaining the data content, I will build then feature e- extraction. Fourth step will be me model building. After building the model, I have to predict, means testing. And final step, visualize the results. So this is what the steps that comes under simple linear regression. In the extract data, what I will do, I will import the pandas package. I will read the data from CSV file or Excel file. In the explanatory data analysis, I will get the information about the data of the CSV file, whether it contains the null values or not, and information about each column and its respective data types. After that, I will do feature extraction, which comes where I will take the x and y, which is nothing but independent and dependent variables. I will separate those features. In the model building, after extracting, I will build a model based on the features that I have. Say, if I have the 100% data, out of that, I will give 70% of the data to the training and 30% of the data to the testing. After building a model, I have to check whether the model is exactly fitted or not, or performing well or not. For that, after building a model, I have to predict. I will do that step here. After predicting, I have to visualize the data. We are between the raw data and final results. Means after predicting what is the expected output, what was the actual output. That the step that I will do here. So let's do this in the next video. I will explain each and everything. Hi everyone. So in the last video I have explained the what are the steps to be carried. So let's start with the extract data code. I will import pandas as pd, and after that I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in I will take data is equals to pd dot read underscore csv. Here I will pass the value where I am ready with this. Control C and paste it here. Make sure that your path is within the double slash, which considered as the escape character. So it will consider the first slash. Let's check whether it is data read or not. Data dot head. If I run this, select the kernel, so it will be going to execute, and I will get the first five rows. Good. So I am having the years of experience and salary, and I will consider the salary as my dependent variable. Okay. In the exploratory data analysis, I will check whether it contains any null values or not. Data dot is null dot sum. So there is no null values, and I will get information about the data frame information info. Good. So it is both are in the float type. Well and good. If it is an object, then it should be the error because it contains null values. Describe. I will check the information about everything. So I have the count, median, standard deviation, mean value, and 25% of total years of experience, 50 and 75, and maximum value. So there is no issues because no null values are there. Now I will go for the feature extraction. So for feature extraction, I will take x and y. In the data.ilog, I will take -1 means except the final one. I will consider everything, or else you can consider like this also. Copy this years of experience and give data within the bracket double quotes column name. You can do that also. Data dot ilog of column comma -1, which means the last column, or else I can write anything is okay. Data, anything can be work. So X will store the years of experience, Y will store salary. Let's check what will happen. First run this, executed, code, print X. Well and good. So years of experience I got. Say next one is print Y. This is my salary. Years of experience, and this is my salary. Now I will the build a model. In the build a model, the step one comes split. Step one 4.1 split data. From to split the data, I will take from sklearn dot model selection import train test split. So x train, y train, x test and y test will come from this method. Means this method will return four values. Those are x train, x test, y train, y test. and here I will pass x and y, which takes only 70% of the data. Test size 0.3 with random state equals to 42 or any number. You can also give any number. Print. Let's check the size shape of the X train shape. X underscore train dot shape. In the same way for the Y train also. For the test, Y test, X test. This will be Y test. Let's run. So here if you see X train and Y train, X train, Y train, I have split it. Next step will be 4.2 train the model. To train the model from sklearn dot linear model import linear regression. Now model is equals to, I will take the reference of the object model. Now I will fit model dot fit x train comma y train. Here I am training the 70% of data. How? I have given entire data set where I am saying that I will keep 30% of the data for the testing and remaining will be 70%. So those 70% is my training data, which is fitted to this linear model. Executed, done. After that, I have to predict the model. What is the accuracy? So testing accuracy is equals to model dot score x test comma y test. Print test accuracy, testing accuracy. Oh, nice. So model is predicting around 94%. 94%. We can find the some more metrics, evaluation metrics. How can you do that? From sklearn dot metrics import mean absolute error, mean squared error, and I will take import numpy as well for the simple mathematical calculations. Numpy as alias numpy np. So I will take train accuracy. You can also find the training accuracy as well. Train accuracy equals to model dot score x train comma y train. Print train accuracy. I think we can also make this as testing accuracy. This is my training accuracy, and I will add mean absolute error (MEAE) variable, and here I will take mean absolute error for x y test. Sorry, for the y test, comma model dot predict x test. So I'm comparing with the y test with the predicting values. So this is my raw, this is my predicted values. In the same way, print MAE. I will copy this step. Mean squared error MSC. Mean mean squared error MSC. Mean absolute error MEAE. And final one, root mean square error. Root mean square error is nothing but the square root of mean squared error. So from np dot sqrt, I will pass MSC directory. So I will print root mean squared error as RMSC. Got it? So I will run this. Let's see. Nice. So training accuracy is my 95% and testing accuracy is also a 94%. So it is good. Now I will visualize the results. To visualize the results, I have to plot. How? I will import the package, import matplot lib dot pipe plot alias as plt. I will plot plt dot plot x test comma y test. This is my raw, means raw data. So this is my test data. So I will label it label equals to testing data, or else I can say tested data, test data. I will plot in the same window with x test and model dot predict x test, which is nothing but y, y prediction. I will label it with predict values. This will predict it. So as I have given the label, I have to display it with legend function, and I will show the plot dot show. If I run this, oh, this is how the results came. So predicted value and testing test data. So it is uneven because the salary is fluctuation. So I will. How can I do that? Take this as scatter. Okay, instead of plot. If I run this again, cool. So I found the best fit tag, and I think I have to arrange set the color. C is equals to color is equals to red, and here also color is equals to red and green. If I run this, this is my best fit rate for the prediction predicted values. I can add the titles plt dot title simple linear regression plt dot x label salaries plt dot y label years of experience. Okay, so in the x-axis I have the okay years of salary. Okay, it should be swapped. I will simply do this as variable. This will be x label. That's it. Done. Okay, and this is how we can build an simple linear regression. In the recap, first I have extract what is simple linear. Linear is nothing but y equals to mx plus c, and this is the simple one equation, simple linear equation with one independent variable. Simple linear regression with, which has only one independent variable, okay, and one dependent variable only. That's it. And to build this model, first I have to extract the data. I have extracted the data. After extracting data, I have explained the data, whether it contains null values or not. If not, then what is the data information and describe the data. I have described. After that, I have done the feature extraction. I have saved the independent variable in X and dependent variable as Y, and I have executed and checked whether it is okay or not. And after that, I have built a model. First, I have split the data in two parts. 30% of the data will go for the training set and 30% of the data to the testing set. And I have taken the linear regression for train the model for with the training set. So this is my 70% of data is being trained to this linear model. After that, I have predicted with the testing data, which is the 30% of data, which gives me 94%. After that, evaluation metrics for a training set and mean absolute error, squared error, and root mean square. This is the values, and this is my visualizing data. This is my data that I have got. So this is my best fit train. So it gives me the linearity. How much fit has been done as per the testing data. This is my simple linear regression. Any doubts? Any explanation you need? Let me know. Thank you. Hi everyone. In the last video, I have explained you how to build a model for a simple linear regression, and today we'll talk about the multilinear regression. So, what is multilinear regression? Say there is an equation, line equation y equals to mx plus c. Okay, this is the line equation y is equals to mx plus c. And here y is dependent variable and x is my independent variable, and this is nothing but simple linear regression. And in the multilinear regression, I have more than one independent variable, like y equals to m1 plus m1 into x1 plus m2 into x2 plus and so on plus c. So this is my multilinear regression. This is what multilinear regression. And one dependent variable and more than one independent variables. This is my multilinear regression. Okay, so the first step, I will extract the data. These are the four steps: extract data. Next, I will get the details of the data. I have to explain the data. EDA is nothing but explanatory data analysis, where I will check any null values are there or not. The third step, feature extraction. The fourth step, model building. The fifth step, evaluation. These are the steps that comes under the multilinear regression. And one more new step comes within the feature extraction is scaling. Feature scaling. Okay, this is how these are the steps that comes under multilinear regression. And in the next video, I will explain how to build a model and Python code using sklearn. For the building and multilinear regression, I will use module name called sklearn. Sklearn. So this is the module. Let's talk about the next video. That's it from me. Thank you. Hi everyone, welcome back. So today we'll continue with the multilinear regression, and in this video I will explain how to build and measure a multilinear regression model. And the first step is my extract data. For extracting data, I will import pandas as PD. This pandas will read the data from the CSV file. Data variable which stores the data read from the CSV file. PD dot read CSV. Within double quotes, I will paste my file location. In the path, you have to give double slash to consider the slash data dot head, which returns the first 5 rows. Python environment, kernel detected, conda environment, and now I am having the multiple independent variables. What are those? Let's see what we will get. It is still connecting. Once it is connected, it will go to execute. So these are the column names: R&D spend, administration, marketing spend, state, and profit. Okay. So I will check first what are the null values present or not. I will check whether the any null values is there or not, missing values. And here profit is my dependent. Sorry, profit is my y, and independent will be state, marketing, speed, administration, R&D spend. And we have to consider whether it is considered as the independent or not. For that, I will explain you in the EDA. Okay. So in the EDA, explanatory data analysis, I will initially check whether it contains null values or not. Is null dot sum. If I run this, okay, there are no null values. Let's get the information. Okay, float object. So I have to consider change it to float. In the initial simple linear regression, what I told is if there is an object, then you have to convert into integer or float type. Data dot describe. Okay, so these are the description of the data frame. Okay, now in the next step I will use the feature extraction, but before that I have to change this object to float or integer type. How can I do that? For that, from scalar dot pre-processing import label encoder. Now take LE as reference for label encoder. Now label encoder will change the this categorical variable column as the integers. So I will take as state, or we can use -2 also, no issues. Data of is equals to le dot fit transform data of state. So if I check the data dot head, did you see? Earlier it was the string, and now it converted to integers. One. What does it mean? Means this one is mapped to one v- value, that is Florida. Florida considered as one, and two is mapped with New York, and California with 0. So it is mapping with the integers. So finally we have converted it. Conversion done. Now before cutting the feature extraction, means x and y, I will check whether the data is exactly correlated with dependent variable or not. For that, I will import cborn as SNS dot pair plot for data. So it will give me the linearity or not. If it is linear, then it is considerable, else not considered. If you want to see the correlation, if it is near to one value, then we can consider data dot correlation and not equals to. Okay, while explain. So if you see this graph, it will give me the linearity graph. So profit and R&D spent is linearity because it is something in the straight line, looks like in the straight line. And administration is something is scattered, and the state is linearity, but it is something exactly not, which is in the categorical 0 1 2, and in the marketing strategy it looks like something linear. So if I consider this and this, the model will be good, and I should not consider profit and profit because profit and profit is always one. So let's see the correlation. Okay, so this, if this is my y, and my independent variable will be R&D because it is nearest to 1, 0.9, and 0.2. I think we can also consider, but model will be not good. Okay, we can consider, and which is 0.1. It is very bad, but which is not exactly dependent on this y. So I will consider the x as data dot index location starting from all, including all rows for except -2, because I will not consider this profit, I will not consider this state, but rest of everything I will consider. That's why -2. So -2 means excluding state, I will consider everything from this side. Okay, I got it. Now in the dependent variable data dot index location, in, consider all rows and only the last column dot values values. If I check the values for x, print x. Yes, I got it. Print y. Okay, so now I have to scale the features. For the scaling the from scalar dot preprocessing import standard scalar. I will take as the reference standard scalar, and I will apply this to this x. So before that, I have to give train test split. I have to split the data from sk learn dot model selection import train test split x train x test y train y test equals to train test split for x and y with the test size. I will use 30% of the data as test set. So remaining 70% will be my training set. Done. Now I will use xtrain replace with the standard xtrain dot fit transform x tree. In the same way for the test also, sa dot transform x test. Okay, so now in the model building, I will take linear regression from sklearn dot linear model import linear regression, and model will be linear regression. Now I will fit this model to the training set. Model dot fit x train comma y train. Okay, good. So till now what I have done is I have checked the correlation with the y, and if it is nearly to the one, the profit is exactly dependent on the independent variables. And in the feature scaling, I have first splitted the data as X train and Y train, X test and Y test. And this train test split will divide the data set into two types, two halves, where it consider as half part will be for the training, half part will be for the testing. And those values will be stored in these variables. And I will fit the standard. I will do the standards scaling for extrain and extras to handle the data frame of the training and test set. And in the model building, I will use linear regression to fit the model, which having the multiple features and one dependent feature. So here I am having the multi-linear regression model. It has been initialized. So next step I will do the evaluation. So for the evaluation, I will to consider the metrics from sklearn dot metrics import R2 score, mean absolute error, squared error, and some mathematical operations for that numpy as np. So my test accuracy or score equals to model dot score x test comma y test, train score equals to model dot score x train comma y train, print testing score test score, print trained score train score variable. Now mean absolute error, mean absolute error for y predict. So I will consider y pred equals to model dot prediction for x test underscore test, and I will check the mean absolute error between y test and y print. So in this y print, I will having the predicted values for the x test. I will complete now. I will take the absolute error between the y original values and predicted values. In the same way for MSc, mean square error mean squared error. I will create y test, comma y pred. Root mean square RMSC equals to np dot sqrt for MSC. Print MAE mean absolute error value will be MAE. Print. Okay, so this will be MAE. Print MSC will be my MSC. Print RMSC will be RMSC. If I want to see the what is the R2 score also, y test, comma y pred R2s. Print R2 score will be my R2s. If I run this, I got this. This is a testing score of 0.88, training score 0.97, and absolute error, squared error, root mean square, the R2 score. So if I want to know what is the coefficient also, we can also find. So coefficient means C. In the line equation y equals to mx plus c, I will find C. What is the intercept? So for that, intercept or coefficient, COEF. Intercept or coefficient. Okay. For that, model dot coefficient, and I will have the slope also. Slope equals to model dot intercept. Print inter CEPT or constant will be my COF. Print slope slope values, which will return array of integers. Why? Because in the multilinear regression I am having the multiple independent variables. For each independent variable I will having the individual slopes. Okay. Slope values are slope. If I run this, this is my const. Okay, okay, sorry. This is these are this is the intercept, and coefficients are slopes. This is what I have. Okay. So just a small recap once again. I'm having the multilinear regression. Y equals to mx plus c is my simple linear, and y equals to m1 x1 m2 x2 plus c. So this is the my multiple linear regression where m1 m2 are the slopes and x1 x2 are the independent variables. And I have done the extraction of the data, and checked whether it is null values or not, and got the information about the data frame. In the data frame, I am having the object, so I have consider changed it to the integers by mapping the numbers using a label encoder, and feature extraction. I have plotted the pair plot for check the linearity and correlation. For correlation, I have used the heat map and annotate with the value, annotate for seeing the correlation values. So I found that in the for the profit, the R&D, administration, and marketing speed are nearly to one. So I have considered these three only. So I have taken X and Y variables for independent and dependent. And in the feature scaling, I have first step is my to uh, split the data as training set and test set, and using standard scalar on independent variables. And for the model building, I have taken the linear regression from linear model, and I have applied the evaluation metrics. And now this is my steps to find the what is the slope of the multiple lines, multiple features. So this is my slope, and this is my intercept. This is how you can find the values. That's it from me. Thank you. If you have any doubts, pin me in the comments. Hi everyone. In the last video, I have explained you how to build, test, and predict the model for multilinear regression. So in this video, I will explain what is a logistic regression. So in the logistic regression, we will predict the output which is categorical. What does it mean? Let's suppose y equals to mx plus c. Consider this as a line equation, and y is mm, dependent variable, and x is independent variable. Okay, so here the y is categorical, means that is yes or no, 1 or 0, or true or false. Okay, so y contains the values like these are the values. Either it will having the values, output values as 0, 1, yes or no, or true or false. So y is the categorical in the logistic regression. Okay, whereas in this SLR is in sim- simple linear or multi-linear regressions, y is continuous variable. So what I want to say is, in the logistic regression, the categorical y is the categorical value, whereas in the previous videos, what I have explained in the simple linear and multilinear regressions, the y is continuous variable. That is why we are using logistic regression in case if the y having only two values, only two values. If there are multiple values, different values, then we have to give linear regression, otherwise logistic regression. So what are the steps to be considered to build an logistic regression? As we know, the first step to extend the data, the second step EDA, explanatory data analysis. Explanatory data analysis. The third step, I will have the feature extraction. The fourth step, model building. The fifth step, evaluation, model evaluation. And the final one, visualize the results. So these are just steps that is required for the logistic regression. It is similar to the simple linear regression, only you have to change the logistic regression. You have to just apply the logistic regression to the model. In entire every step is different. You can also try once, and in the next video, I will explain how to build a model. That's it. Thank you. Hi everyone, welcome back. So, in the last video, I have explained what are the steps to be considered while building and logistic regression. So let's start with the extract data. So I'm having the file social network ads. I will copy this path, and already I have copied. So I have to import pandas for reading the data as pd data equals to pd dot read csv. Within this, I will pass the file folder path. Data dot head will give first five rows. If I run this, I will having the data frame, having the column names is estimated salary and purchased. So in the purchased, I have the category value. If you see here 000, these are the category value, means either contains 0 or 1. Let's see what I am telling. Data dot ilog all the columns till considered as 15 for minus 1. So if you see here, I found only one, and only 0 and 1 are there in the category in the purchased, which is the target variable. Target variable is nothing but the dependent variable y. Okay, so in experimental data analysis, as you know, I have to check whether it contains null values or not. Is null dot sum. Okay, no null values, so I will check the information about data frame. Data dot info. Okay, integer, no object. Data dot describe, I will check the description of the data frame. Done. So let's go for feature extraction. So in here I'm having the three columns where the purchased is my y dependent variable, and age and salary, estimated salary is my independent variable. I will consider x, which contains data frame with index location starting from 0 to last all the rows for all the columns except the final one. Dot values, which converts this data frame into numpy 2D. Done. Same way for the target variable, dependent variable, I will consider only last one. So index location for data frame data, I will consider all the rows for the last column and convert it into numpy dot values. Done. So I will check what are the values. Print x. If you see here, it is in the 2D array. This is my age, this is my estimated salary. Let's see. Print y. I have to get the predicted. If you see here, only 0, 1 are there. So this is the categorical value. Now, first step of the model building. Next to go for the model building. In the model building, my first step is to split the data into two halves. One is training set, another one is testing set. From sklearn dot model selection import train test split. I will take four variables: x train, x test, y train, y test. So these four values will come from this function train test split, where I will pass the data x comma y and telling that I need training set of 70% of the data to be trained. So for that I will use test set equals to 0.3. So 30% of the test data and 70% of training data with a random state of 42. You can give like this. Let's see what is the shape of the x and y training set and test set. Train shape, train data shape is x train dot shape. I will copy this. I think shape will not work because I have converted it to the value. So for now, let's comment it. X train shape and y train shape. Y train shape. The same way for the testing also. X test and test. X test and y test. So I have to execute this once again. If I run this, I found 280 and 120. This is the shape of the training set and data set. After this, I will use the standard scalar for arranging them in the proper dimension from sklearn dot reprocessing import standard scalar. I will take the reference as the in the within the variable using the variable standard scalar sc. I will convert. I will arrange the dimension of x train so that sc dot fit transfer x train. For the x test also, sc dot transfer x test. So till now what I have done, I have prepared the data and using standard scalar, I have standardized the dimension. Next, my model building. So I have to train the model. For the training the logistic regression model from sklearn dot linear model, I will import logistic regression. I will take a variable for logistic regression. Now I will fit the training data set model dot fit x train comma y train. If I done this, logistic regression model has been trained. Now we have to start with the model evaluation. So in the logistic regression, we can use the metrics of you for accuracy score, F1 score, R2 score, mean square error, root mean square error, a confusion matrix also. For that, first step is my from scalar dot matrix import R2 score, F1 score, mean absolute error, squared error, and confusion matrix. For normal mathematical calculations, I will import numpy. Import numpy as NP. So test score test underscore sc equals to model dot score x test comma y test train score train underscore sc equals to model dot score x underscore train comma y underscore train print testing score is test sc. Same way, print training score is my train sc, and I will find the R2 score, R2s. So before that, okay, before this, I have to get the Y predict. So this is my testing score, and the training score is found 85%, and training set is 82%. Okay, it is more than 80%. Now Y predict equals to model dot predict. So I am predicting values for X test using the logistic model. So in this model, I have the logistic regression, and I am predicting for X test, and I will print Y pred. So this is my predicted values. So for the on this, I will find R2 score, F1 score, mean absolute, mean square, and confusion matrix. So first step is R2 score equals to R2 score for Y test and Y predict. Mean absolute error. Mean absolute error between Y test, comma Y predict. Mean squared error MSC variable which stores the value of mean squared error between the dataset Y test and Y predict. Root mean square, which is the square root of np dot sqrt, the square root of MSC. I will print, and one more step is F1 score. F1s equals to F1 score for Y test and Y predict. So I'm finding the R2 score, mean absolute, squared error, root mean square, and F1 score between the raw output and expected output. Okay. Actually, this is my expected raw output, and this is my predicted output. So, what is the difference? If there is a small difference, then the accuracy and prediction model is good. Okay. So, I will print those values. R2 score, R2s, print mean absolute error, MAE, MAE, print MSC, mean squared error. MSC, print RM root mean square RMC found by RMC variable. Print F1 score. F1 score. If I run this, I found all the values. So mean absolute error, square error is less than 2, and root mean square is something around 0.3. It is okay, okay. Why it is coming like this? F1 score. Okay, I found F1S. It should be F1S. If I run this again, okay, nice. Now I will build a confusion matrix. CM variable confusion matrix. I will pass the dataset, actual dataset and predicted dataset. I will print CM. So this is the 2D matrix which contains true positive, true negative, false negative, and false positive. And now let's visualize the results that I have done till now. For this, I will import matplotlib matplotlib.pyplot as plt, import numpy as np from matplotlib.colors, import listed color map. So except, I will take except equals to sc dot inverse transform of x trait and y underscore set equals to y train. Now I will take two variables x1 x2 which is written by np dot mesh grid, will pass np dot arrange. I will have three values here in the range: start, stop, and step. Start equals to stop is equals to step. Okay, same way I will have one more: start, stop, step. So in the start I will have except, I will consider all rows for 0 where minimum value minus 1 to consider the initial one. Paste except, I will consider all the rows for the 0th column dot maximum value plus 10, the step size say 0.25. In the np.arrange start except, I will consider all the rows for the new column, next column, which is 1, and the stop dot minimum value minus 1000, which is the salary column. The stop will be, I will consider all the rows for the next column dot maximum value plus 1000, step size same 0.25. You can take anything till now. Okay, the machinery. Now I will plot this for plt dot counter f for x1 x2, where I will model dot predict sc dot transform np dot array, where it takes two x1 dot ravel comma x2 dot ravel. I will use the transpose for this sc transform, and I will reshape it to x1 dot shape, x1 dot shape, comma something dot. So now I will use alpha equals to 0.75 and C map, which has the distilled color map, and I will tell to plot with the color red and green. Okay, so here I will have the for I comma j in enumerate np dot uni y set, where I will get 0 or 1. Now I will plot this as a scatter plot for x set, where my y set equals to 0, 1 for 0th column, and x set where y set equals to I for next column, where my color will be listed color map red and green, red and green with index I. So it will map for which 0 for which 1, it will plot that those colors for that only. So label will be J. plt dot present for plotting the label for the final plot plt dot show. If you are interested, you can plot x label with salary and plt dot y label is, you can add title plt dot title as logistic regression, logistic regression. So if I run this, it will take around 3 minutes to plot everything. First, it will plot the counter F, then scatter plot. Means on the total colored plot, it will give you the colored image, colored scatter plot, which differentiates between 0 and 1. So let's see what will be the output. Let's check. So just a small recap once again. So first step, I have extracted the data, and after the extracting data, I have explained the data, what the data is about. So I checked whether the null values or not. Then information, and then I have checked whether the data is within the integer or float type, and description, and I have extracted the features in x and y variable, and I have printed, and you can also change it to dot values as well. And if I change it to dot value, then you no need to write this print text, train shape and y train shape, x test shape, y test shape. And here I'm having the standard scalar, and this is the logistic regression. And then in the evaluation metrics, I have you found the score, testing score and training score for the y test and y train. And then using the prediction values, I have found the r2 score, f1 score, mean absolute squared error, and confusion metrics. And these are the evaluation metrics, and I found that there is an error less than 2.2, and this is my confusion matrix, which contains true value and false values for positive and negative. And after visualizing the results, this is what the plot. So okay, this should be the age and this should be the salary. So I have to change this as to y, and this has to be x. I think it should not throw the error. If it throws the error, you have to run all. Let's wait and check whether what will the output, the plot. And I think you can also remove this warnings with import warnings dot import warnings, and warnings dot filter warnings ignore. Now it is okay. This is the final output for the logistic regression. That's it from my end. Thank you. If you have any doubts, let me know. Hi everyone. So today I will tell you about the SVM, which is also called the support vector machine in the machine learning, and it is used for both classification and regression models. Support vector machine. Okay, actually, this algorithm is for both regression and classification. Both classification regression problems in the machine learning. And for to implement this, my first step will be extract data. Second step, we know EDA, which is also called explanatory data analysis. And third step is feature extraction. Fourth step is model building. The fifth step, model evaluation. The final step will be my result visualization. Visual. This is the steps that required to build an SVM. In the next video, I will explain how to do that. So stay tuned. And if in doubts in the previous videos in logistic regression, multilinear or simple linear regression, let me know in the comments. Hello. So in the last video, I have explained you what are the steps need to be taken for implementing the SVM machine learning model. So first step is by extract data. Let's do that. So initial step is to extract the data by importing the pandas package, which helps in reading the data from the CSV files or Excel files as PD. Data is equals to PD dot read CSV double quotes. Within this code I will paste the file path, and before that make sure that you have to give this here a backslash or opposite slash to consider the slash so that it can read. If I read this is my data frame, position, level, salary. So in the explanatory data analysis, I have to check whether does it contains null values or not. For that, data dot is null dot sum. It will give how many null values are there. So currently it is zero for all columns. Means the data frame it doesn't contain any null values. Let's proceed with the information. What the information does it contains? Data dot info. Next, data dot describe. So it gives me the description of the data frame for each column, level and salary. And now, as we know, in the information, if it is an object, we have to convert it into integer or float. So for that, the feature extraction, I will initial change that one from sklearn dot preprocessing import standard scalar and label encoder. LE is equals to SC is equals to standard scalar X is equals to. So before X we have to add one more thing is X equals to data dot ilog includes all the rows starting from 1 to -1 till the values, and in the y also data dot ilog all the rows for last column and convert it to values numpy array. If you check that, print x is print y. So for each one I have converted into 1 to 10 and its respective salaries. X equals to sc dot fit transform of x and y is equals to sc dot fit transform for y dot reshape, where the number of rows will be number of length of the one, the y and 1. So I'm converting it. Then now I have to build a model. I have to train, I have to split once the data from scale dot model selection import train test split x train comma x test comma y train comma y test, where my values will come from this function where I pass x and y. So when I pass this test size 0.2, which means, or 0.3, which means this train test split function returns the four values x train, x test, y train, y test, where I am passing the parameters x and y and test size, which tells that to split this x and y data frame into 20% of data is test and remaining 80% will be for the training. If I check the shape of x train, x underscore train dot shape, in the same way I will copy this entire line for checking the shape of the y train also, and for same thing for the test size as well, x test and y test, x test, y test. Where in this, okay, so there are total 10. If you see here there are total 10. After splitting the data, the 70-80% of the data is for training set and 20% data for the test set. If I change this to 3, then 7 is to 3. Okay, so for now I am taking as 2. Okay, so after this, after the splitting the data, you have to apply the model from sklearn dot for svm. In the sklearn there is an svm package, in that the model name svc and svr. Within these two, this is the for the classification, svr for a regression. As we are talking about the regression model, I am considering svr. Now my model is equals to, I have to initialize this svr and model dot fit x train and y train. And I have to mention also that kernel should be RT or linear. If I run this, done. And we can also remove this warnings with importing warnings and warnings dot filter warnings with passing the value ignore. Now after fitting this, let's go start with the model evaluation. For the model evaluation, I will consider metrics from sklearn. Sklearn dot metrics import R2 score, mean absolute error, squared error, import numpy s and t. I will find the test accuracy. Test accuracy equals to model dot score. I will pass x test and y test. X test and y test. Train score model dot score. I will pass the values. I will pass the dataset x train and y train. Print testing score is score and print train score is train score. Parenthesis, I have found that 57% and 70% for testing score and training score respectively. Now I will find R2 score. R2s variable which stores the R2 score, but before this I have to find the I have to predict the value. For that I will use ypred is equals to model dot predict, and I will pass the value x test. Print ypred. For n this I found two predicted values. So R2 score is my y test. I will find the R2 score for y test across the y predict. In the same way, for the mean absolute error also, I will pass y test against the y predict. Mean square error also, I will pass y test comma y pred for the root mean square np dot square root of mean square error. Now I will print those values. Print R2 score is R2s. Print MAE mean absolute error. MAE print square mean squared error. MSE is MSE print root mean square error. RMSE. I will give RMSE. Okay, so I have to give comma. If I run this, I found these are the root mean square, R2 score, mean square, and absolute error. And now we have to analyze the results. For that, I will import matplotlib. I will to change it to Python so that I can colored dot pyplot as plt. So I have to plot for sc dot inverse transform of x, comma sc dot inverse transform of model dot predict for np dot array of x dot reshape -1 comma 1, where I will tell to color I have to color is red, red, and plot same for scatter for sc dot inverse transform of x comma sc dot inverse transform of y, and for this my color will be c is equals to plt dot show. If I run this, it is asking for the 2D. Something happened here. So np dot array, I'm passing the x. Let's check the plot xvc predict model dot predict. So I will copy this. Let's see what will happen. Nice. So there was some mistake. So this is what I'm getting. So what is happening? I'm plotting the graph line graph for inverse transform of x and inverse transform of predicted value of x by reshaping it to 1D as 2D. Sorry, it is converting it to 2D and plotting with the red line. This is my red line. So this is my predicted graph, and I'm using the scatter plot between the inverse transform of x and y. So I'm not using the training set and test set. I'm passing entire data set x and entire data set y and plotting it. So this is blue lines are my actual one. This is my predicted one. This is how I'm plotting. So these are the steps to build an SVR. If I'm saying that find, I want to apply the SVM for the linear linear model applied. Now I will test see the test accuracy in the further linear. Okay, it's coming less than 1. So this is my linear. If you see here, it is my linearity straight line. If you want to find the further kernel RPF, then don't use linear, use RPF. Done, 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 done. And if I run this, now the linearity will be not there. It will be the curved line. This is a curved line. So this is the difference between the linear and RPF for SVR. So using the kernel, we can initialize whether the SVR is for linearity or not, or continuous values. This is how you can implement the SVM in regression. So in the next video, I will try to implement much more examples. And if you have any doubts, let me know. Thank you. Hi everyone, welcome back. In the last video, I have explained to you what is the support vector machine and how to build that model and train, test, and visualize the results. And in this video, I will continue with decision tree. So, what is a decision tree? And actually, the decision tree is where we can decide uh, and simplifies their decision making process. So, in the simple statement, I can tell that it is a type of flowchart which helps in decision making process. This simple way, I can tell that it is a type of flow chart or diagram which helps in decision making process. That's it. It is nothing more than that. Okay. So first step will be my extract data. Next step will be my to check what are the null values which comes under the EDA, which is also called explanatory explanatory data analysis. To where I will check the whether it contains null values or not, and what is the type of the data it contains, and everything about the data frame. Next, feature extraction. After the feature extraction, I will build a model building for the decision tree. Next, I will evaluate the model evaluation. In the sixth step, visualize the graph. Okay, so these are the steps that to be followed for the decision tree. So what are the steps? Once again, extract data. After extracting data, I will check whether null values are or not in the EDA. If the column contains integer or float or object, and in the feature extraction, I will take out the train test split for 30% of data for the testing and 70% of the data for training. And in the model, I will fit that training set. And after model fitting, I will check the model is trained proper not by using the evaluation metrics using MEA, mean absolute error, squared error, R2 score, test score, and training score. After that, I will visualize the tree map and decision making graph. I will make the graph for decision tree. That's it. These are the steps to be taken. So in the next video, I will implement those steps. Stay tuned. Thank you. Hi everyone, welcome back. In the last video, I have explained what are the steps required for a decision tree. And decision tree, as we know, that it is the type of the flowchart or diagram which helps in the decision making process. If the word comes decision making process, which algorithm is used, then we can directly say the decision tree. And by the way, it is also used for in. It is also used in both regression and classification. Okay, this is just similar to the SVM. So SVM and decision tree also used in both regression and classification. So first step is my extract data. For extracting data, I have to import the pandas package as pd. Data is equals to pd dot read CSV file. I have already copied the path. I will paste it here. Data.head will give first 5 rows. Let's check what it will be. What are the values? Slash, backslash. Make sure that before running you have to give double slash or single opposite slash. So these are the same data frame. So I'm having the position analyst, levels and salary. Object is my position. So in the data analysis, I will check whether it contains null values or not using data dot is null dot sum. If I run this, there are no null values. Data dot info information is object integer. I have to change this object to an integer of float. So before that, let's complete it. Description dot describe. Now in the feature extraction, my initial first step will be to convert this object data type of our position. I will copy this position name. First, I will change it by importing label encoder from sklearn in pre-processing. Import label encoder ld is equals to label encoder data of the column name equals to ld dot fit underscore transform. I will copy this column name, so I'm converting it into the integer. Now if I check data dot head, everything is changed. If you see here, before it was object, now it is the integer. For verification, we can data dot information integer is converted into the integer it is converted. Now let's begin with the model building. For the model building, first I have to get feature extraction. For the feature extraction, x is equals to, in the third step only, in the feature extraction I will give data dot ilog include all the rows except the last column. Y is equals to data dot ilog include all the rows only last column. If I execute this and I will print x, position interval got it. If I check print y, I will get this analysis. Okay. Now come into the model building. First I will split the data model sklearn dot pre-processing. Instead of pre-processing model selection, import train test split and x train comma x test y train comma y test, and these four values comes from the method train test split, which takes the parameters x and y, where test size I'm giving as 0.3. If I check the dimension or shape, x train shape is x train dot shape. In the same way, for the y train also, I will copy this I will just change this by I will change this by and for the test size also let's check. For that I will change this as test, double click and paste it. Double click, just change this to by double click, copy and paste it here. If I run this is what total 10 rows are there. 30% means 3 rows went for the testing, remaining 70% for training because I have given the test size as 0.3. Now I will to use standard scalar for dimension reduction from scalar dot preprocessing import standard scalar SC is equals to take the reference for this standard scalar. Now I will apply for x string equals to SC dot fit transform x string and x test also equals to SC dot transform x test. Run this. Done. Okay. So now it's time for the model building. Train the model. For training the model, I will import the decision tree from sklearn dot tree import decision tree classifier and regressor. Out of these two, what should I select? I have to select decision tree regressor because we are talking about a regression. So for the regression, I have to select the decision tree regressor. If I am talking about the classification, then I have to select decision tree classifier. So I will go with the decision tree regressor. Now my model is for decision tree regressor. Now I will fit the model dot fit with x train and y train. If I run this, valid parameters, what will they be? X train and y train. Uh, okay, the parenthesis was missing. Now done. Till now we have trained the model. Now our next step will be evaluation. For evaluation from sklearn dot metrics, we will import R2 score, mean absolute error, squared error, and for mathematical calculation, I will import NumPy as NP. So my test score, I will find the test score. Test SC is equals to model dot score x test y test. For the training score, train SC equals to model dot score x train comma y train. If I print testing score, test score is test SC and I will print the training score also. Train score is train score. In the same way, I will find R2 score. R2S is equals to. Before that, I will find the product. Okay, it is one because it is train the model is accurately, it should not be one. And y predict equals to model dot predict x test print y predict. This is the predicted values. Now R2 score equals to R2 score. Sorry, R2 score will pass the parameters y test original data into predicted data. In the same way, for mean absolute error also, mean absolute error will pass y test and y predict. For the mean square error will pass y test and y predict. For the root mean square, np dot sqrt I will pass MSC because root mean square is nothing but the square root of the mean square error. Now I print those values. Print R2 score is R2s. Print mean absolute error is MAE. Print square error is MSC. Print RMSC root mean square error is RMSC. If I run this, I found these are the values. So it is much more bigger because I used the wrong dataset. If you use the correct dataset, you may get the correct values. That is why it is coming as 1 and the error as 10 to the power of something around 10 into 8. So it should be the error in the selecting the data frame. If we select the correct dataset, it come around 0.2, 0.1. The R2 score will be something around zero point 0.8 or zero point 0.9. So make sure that you have to select the correct dataset. Now it's time for the visualize the tree map or decision tree graph. Now for that, I will import from the scale. Let me first make sure that it should be the code. Scalar dot tree import plot tree. Now plot tree for the model which fits model dot fit x comma y. I am plotting the graph for entire dataset where the feature names which it comes which considered in the list where data dot columns. So what is happening here is I am plotting the graph for the model which fits entire data set x and y and feature names will be the column names which is should be passed as a list. That's why I am using list. Any clear? Everything clear? So I will plot this plt dot show. For that I will do import matplot grid dot pipe plot as plt. If I run this, I will get the graph. If you see here, the graph has been done. So it is not clear. It is no clear. So if you want to visualize much more bigger, plt dot figure with size in the list give 10 comma 10 size. If you see here, it is plotted better, something better than earlier. You can drag it out. You can make it as x-axis as 15. Now it is clear. If you see here, it is clear. Okay, this is how you can plot the tree graph. And lt dot plot x comma y. So this is the what it is happening. So if I say scatter, so it is coming as from. I think I have to use model predict. Model dot predict x. I have to use dot ilog because here the dimension of x is 2D because I'm considering the position as well as the experience. Whereas the model dot predict x, it will give only one dimension, which is the salary. That's why I'm using ilog. Consider everything. Only the column. Now, if I see, did you see this? No. If I want to plot that, we will consider everything. We will plot this instead of scatter plot. And the color C is equals to red. Done. This is how you can and for this we will give the title twenty dot title decision tree results. Plt dot x label experience or label plt dot y label salary parenthesis. Now okay, fine. This is how you can plot, and this is how you can visualize the decision tree. This is the main step that considered in the decision making process. From this, I can visualize what are the how should the decision should be taken. Thank you. If you have any doubts, let me know in the comments. Hi everyone. So today let's begin with the random forest. And a random forest is nothing but the collection of decision trees, which is used for solving complex issues. So, random forest is it is an algorithm that generates a forest of decision trees. Okay, and also it is based on ensemble learning, which means which integrates multiple classifiers pairs to solve a complex issues and increases a model performance. Okay, so this is what the random forest means. And if I in the while implementing the random forest, what are the steps will be considered? So first step is to extract data. Next one is explanatory data analysis. And for third step is to extract the features. Feature extraction. The fourth step, you will have the model building. The fifth step, after building the model, you have to check whether the performance is good or not. For that, model, this comes under model evaluation. The final step, visualize the results. This is the steps for implementing random forest model. So in the next video, I will implement the random forest algorithm and build that model. And stay tuned. We will explain you in the next video. Thank you. So let's begin with the extract data for the random forest. For extracting data, I will import pandas. Import pandas as PD data variable which stores the re- data frame read underscore csv, which takes the file path data dot head, which displays the first five rows. Before that, make sure you have to give double slash and select the kernel. You have to give the kernel python exe, then start execute. Once it is executed, you will see the first five rows of this file, position underscore salaries CSV file. So this is the data frame or the data which is inside this CSV file. Now I will check whether it contains null values or not. For that, data dot is null dot sum. We run this. There are no null values. I will check the information about this data dot info. Now I found this is the data type of each column. Position is object, so I have to convert it into integer or float. For that, I will use the label encoder. Before that, let's complete with the description. Getting the description. Okay. Now for the feature extraction, before that, I will change the object to integer from scaling dot pre-processing import label encoder. I will take LD variable for a label encoder reference. Now I will convert the data where my position is le dot fit underscore transform. I will update this same column. I also can use data index ilog all the rows for only the first column. I can use this also instead of position. So it is your choice, whatever you want to use. Data dot head. If I run this, everything is changed. Okay. Now after this, I will split the data. Before that, I have to mention which is independent, which should be the dependent. For that, data dot ilog all the rows is included and except last row. Data dot ilog I will consider all the rows only for the last column. Let's change it to values. Dot values. Run it. Now execute what is the check the value of the x and y. Print x. Now print y. Done. Now it's time for the model building. So first I have to import from sklearn dot model selection import train test split, and I will take xtrain xtest by train y underscore test, and these four values comes from which is written by this method x and y train test split, where I am passing the x and y values with the testing size of 0.3. If I check the shape, xtrain shape is x underscore train dot shape. I will copy this and I will paste again for y train, and I will copy this again for test size. So it is same for everything. Xtest, xtest, ytest, ytest. Run it. That's it. So xtrain and ytrain having the 70% of the data, xtest and ytest with the size of 30% of the data. Now I will use standard scalar from sklearn dot preprocessing import standard scalar sc equals to standard scalar. Now I will change the format of xtrain by sc dot fit transform of xtrain. Now I will change the xtest also. I will update xtest also by applying sc dot transform method. X test run. Now it's time. Now it is the time for applying the model. So for the random forest, I will import sklearn dot ensemble from ensemble import random forest regressor. Sorry, random forest regressor, because I am talking about we are doing the regression model. We are building the regression model. For that, I will use regressor, random forest regressor. In case if I am talking or building a model for classification, then random forest classifier. So for now, I will use random forest regressor. Now model equals to initialize this random forest regressor, where it takes estimators up to 10 and random state. For now, let's start with 0. Anything you can use. Model dot fit x train comma by train. So what is happening is I am applying the random forest regressor with estimators of number of estimations is 10, and with the random forest 0 in training the and building the model for and applying the training set for this model. So training done. Now it's time for the evaluation. For the evaluation, I will import from sklearn dot metrics import R2 score, mean absolute error, squared error, and import numpy for normal mathematical calculations as np test underscore testing score. I can find the testing score also by model dot score. I will pass I will pass x test comma y test training score train underscore sc variable, which stores the value for model dot score. I will pass x train comma y train. If I print those two, test score is my test sc, and print train score is train.sc. If I run this, I found this is the test score and training score. And you have to give the proper data frame so that the prediction can be done accurately. It should, it will be the positive. Next, after this, I will find the R2 score mean square error. R2s equals to, okay, before this you have to predict the values. Y pred equals to model dot predict x test print underscore pred. Okay, so this is the 30% of the data has been tested, and this is my predicted values. For this, I will find the R2 score. R2 score for y test, between the y test and y pred. Find the R2 score for raw data and predicted value. MAE equals to mean absolute error y underscore test comma y underscore pred. MSC is equals to squared error, mean squared error by passing the y test and y product. So here what is happening? I am finding the mean absolute R2 score squared error between the raw data and predicted data. And RMC is nothing but the root mean square error. It can be found by The square root of mean squared np dot square root of mean squared error. Let's print those values. Print R2 score is R2s. Print mean absolute error MAE. Print MSC mean squared error. Print RMSC is root mean square error. Done. Okay, so next step will be visualizing the results. For visualizing the results, I will import. Let's change it to the code to cell to code. Import matplotlib dot py plot as plt plt dot plot x. So this is the x value, but you need only the first column. So I will use dot ilog. So earlier I have used dot value. That's why the ilog is not needed. You can use directly against y test or y anything. Okay. So for now I will use plt dot plot x. I am passing entirely comma model dot predict. I'm predicting whole of comma 1 plt dot show. And I can you apply the give the title plt dot title result visualization. You can give plt dot x label x axis as position. I think it is experience or position. Let's see. Okay, it is x axis is my level. What is my level? Based on the level, you will have the salaries level. PLT dot y label is my salaries. Salaries. Now, if I run this, I will get the result. What is happening? Okay, expected 2D array, but got 1D instead. So, what was the issue? PLT dot y label x label. If I comment in this, okay, this is the graph. Salaries level. So salary is something 1 e to the power of 6 exponential of 6. So this is how it is increasing the exponentially. This is the correct way. Okay, that's how you can predict the values. That's it from me. Thank you.